Now we're going to look at problems involving the use of isosceles and equilateral triangles. For this problem, we want to find x and y, and if you look carefully, this triangle right here, KNL, is an equiangular triangle. Since it's equiangular, we also know it's equilateral, so these three sides will be congruent, and that means that y is equal to 4 as well. Now, Kn is equal to 4, Ln is also equal to 4. If we look, we can see that LNM and LMN are congruent, which makes triangle LNM an isosceles triangle. So not only are these three sides congruent over here, we know that Ln and LM are congruent. Since Ln and LM are congruent, we can state that x plus 1 is equal to 4, and subtracting 1 from both sides, we can state that x is equal to 3. Going through this again, we know that KLN is equiangular, so it's also equilateral, and KN and KL are congruent, so y equals 4. Now we can state that because LNM and LMN are congruent, that LN and LM are congruent because it's isosceles. So since Ln is equal to 4, we can state Ln and LM are equal. We plug in our values, we substitute, and we get our answer x equals 3. For this next one, we want to look at two triangles here, and we want to be able to prove that QPS is congruent to PQR. Now, one thing that helps a lot of times is when you see triangles like this where they're overlapping, again we have QPS and PQR. The best thing for you to do is to draw the two triangles separately and then just label the parts appropriately. So I'm going to draw them. It doesn't have to be perfect, but we know those are the two triangles, and here's P, here's Q, here's S, here's P, here's Q, and here's R. We're told that PS and QR are congruent. We're also told that QPS and PQR, those angles are congruent. Finally, we can see that PQ and PQ are congruent using reflexive property, and so the two triangles would be congruent by side angle side here. Now, if you notice, they've labeled angles 1 and 2 here, so we can also label this angle 2 and this angle 1. And we're going to use that for the second part of this. The second part of this asks, explain why PQT is isosceles. Well, if we go back to the picture, we know that angle PQS right here, which is angle 2, and angle QPR, which is this angle right here, are congruent by CPCTC, which we learned in section 4.6. And if we go back up to the original picture, we can see that those two angles are here. So since those two angles are congruent, we know PT and QT are congruent, and triangle PQT is isosceles. And finally, we want to show that PTS and QTR are congruent. Let's take a look at this and see if we can do it. So we're talking about this triangle right here where we already have one side here and here, and we already know that angles 3 and 4 are congruent because of CPCTC, and we also know that these angles right here are congruent because of vertical angles. So we can state by angle, angle, side on both of these that the two triangles are congruent. And again, they separated them. We can see our angle and side, and then angles 1 and 2 will also be congruent. So therefore, they're congruent by side, angle, side. And then since 1 and 2 are congruent, we know that PT and QT are congruent, making it isosceles. And finally, we know angles 3 and 4 are congruent, and again we know PS and QR are congruent. So as I showed you before, by angle side, the two triangles are congruent. And now we want to take a look at this and see if we can prove it by side. This is a little bit trickier, but I'm going to go over it. I'm going to zoom in on this picture so that we can see it. So we want to do side this time. Well, we already have this given to us because it was one of the original things given. We know that, let's see, we know that QS and PR are congruent because of CPCTC, and we proved that these were congruent because these two angles were congruent. So if PT and QT are congruent, and the whole thing QS and PR are congruent, we can use the segment addition postulate and state that since PT plus TR is equal to PR and QT plus TS is equal to QS, and we already know the whole lengths are congruent, we know these short ones right here, PT and QT, are congruent, then we would know that TS and TR are congruent. And again, we've already proven that these are congruent when we showed that PQT was isosceles, so now we have our side. And I think that's it for this one. We'll take a look. So again, we know that QPT and PQR are congruent, so QPS and PQR are congruent, so we use the segment addition, we use the segment addition postulate, and it's a little bit confusing here the way that they do it. I think my way makes a little bit more sense. So again, we use the well, we don't need to use the reflexive property in that case, but that was given to us, so we did our side for this one. Alright, for this last problem, we want to find x and y. If we look at this triangle right here off to the right, we can see that that is a equilateral triangle, therefore each of these angles is 60, so we can say that x is equal to 60. Then, since that's 60, this is 60 down here as well, and since there's a right angle here, we know that this angle is 30. We also know that this angle is 30 up here because this triangle is a isosceles triangle. So we have two 30-degree angles plus the y gives me y. Now let's do measure. Let's say y. Y plus 30 equals 180. So that's y plus 60 equals 180. And subtracting 60 from both sides, we know that y is equal to 120. And I believe that's it. Thank you.